Hi again. In this lesson, we're going to look at hypothesis testing for the difference of two proportions. And we are going to do a simulation in this. We're going to do a physical simulation. So if you'd like to go ahead and get a deck of cards before we start this video, okay? I'll show you how we're going to use it in just a moment. Okay, so let's look at an example here. And we've got two proportions, hypothesis testing. So this is based on a real study, a dolphin therapy experiment. Researchers wanted to know whether swimming with dolphins would be therapeutic for patients with clinical depression. They recruited 30 subjects aged 18 to 65 with a clinical diagnosis of mild to moderate depression. Okay, so they had the participants discontinue any other treatments for 4 weeks prior and during the experiment. The subjects went to an island near Honduras where they were randomly assigned to 2 treatment groups. Okay? All other conditions were identical except for the presence of dolphins. Okay, so this is where we might need to have some blinding and also, the control group, of course. So the dolphin group engaged in 1 hour of swimming and snorkeling with dolphins each day. The control group engaged in 1 hour of swimming and snorkeling each day, but without the dolphins, okay? So the control group may or may not have known exactly, whether there were dolphins involved or not. I bet they would be very disappointed if they knew that they were not getting to be with the dolphins. Okay, so, and the questions we have are identify the response variable, identify the explanatory variable, and write the hypotheses. Okay, so again, just like last time, we have our table in a data. We have our data in a table. I said that backwards. Let's look at which way, where's the response and where's the explanatory, okay? So what is the outcome, right? So I see our 2 groups. This time our groups are columns. Okay, we have the dolphin group and then the control group. And improved and not improved. Okay, so we've got, it looks like we want to know whether, let me underline it here, whether swimming with dolphins would be therapeutic for patients with clinical depression, okay? So it seems like we'd probably want to be interested in whether they improved or not, right? We could also do not improve, but a little more direct, go to improved. So let's put for our response variable whether a person's depression improved. Right? That's the variable we would be measuring for each person, yes or no, in the experiment. Now, of course, there could be not necessarily just a binary, but there could be a range of, 1 to 5 or something like that. But here it looks like there was a improved or not improved, okay? So this is our response or the outcome. We're going to look at the improved row, okay? Now, our 2 groups are, of course, we want to know whether they did participate with the dolphins or were in the control group, right? So those are our groups. So the explanatory is going to be which group a person was in, right? Whether each subject was in the dolphin group or the control group, okay? And because we want to distinguish these 2 groups, let's use a D and a C, okay? 2 different letters just so we can get our distinguish more easily between the 2 groups. We could use 1 and 2 as well. Okay, so let's think about writing our hypotheses, and then I'll show you how we're going to do this physical simulation, and then we will do it on StatKey as well. So, hypotheses. Remember how the null is dull. The null is no effect, right? So the null should be something about there's no difference between the two groups. So still start out with our H naught colon. That would be, and we're talking about proportions still, the proportion of improved, right? So the proportion for the dolphin group, if that was equal to the proportion for the control group, then that would be no effect, right? If they're equal. Now there's another way to write this, and that is with a subtraction. So I'm going to show you both ways. Or we could write P sub D minus P sub Z, C, sorry, too many letters, P sub D minus P sub C equals 0. Okay, so that's another way of saying the difference is 0, which means they're equal to each other. Okay, if you think about algebra and you added P sub C to both sides, you would get this one over here. Okay, now the alternate, HA, is the claim. They wanted to know whether it would be therapeutic. So they wanted to know whether the people swimming with the dolphins improved, right? So that would mean the improvers in the dolphin group, PD, would be greater than PC. Okay, so dolphin, this would mean dolphin group improved. Or to write it as a subtraction, very similar, P sub D minus P sub C would be greater than 0. So if the dolphin is bigger, dolphin group is bigger, bigger proportion, then the difference should be positive. Okay, great. So now we're going to do a simulation and see what's likely under the null, right? So remember, when we do a hypothesis test, we're simulating the null distribution, or we're assuming the null is true. So we're assuming there's no difference, okay? So let's look at our table a little bit more to see how this is set up. So we want to measure the improvers, right? So there were 10 improved in the dolphin group and 3 improved in the control group. Okay, and remember, we want to use our group totals, right? It was going the other way in the previous example, so we always need to look at the table carefully and see which way we're going. The dolphin group has a total of 15, and the control group has a total of 15. Okay, so again, they're equal to each other. So we could write an N1, or actually ND and NC to match our letters. Okay. Another interesting thing to know is if we look at this total, there were 13 who improved overall, right? And then 17 that didn't improve. So when we set up our simulation here, I'm going to be using the 13 and the 17. I'm not going to circle the 17, but let me show you how this is going to work, okay? So if you're doing this in a class, you might have access to these little blue cards like this. Otherwise, you can use any deck of cards, and I'll do it one of each way, okay? The most important thing is that we have 13 cards that are going to be improvers and 17 non-improvers, okay? So the idea is, if we're simulating the null and we're saying there's really no effect of the dolphins, then those who improved would have just improved either way, right? It didn't have to do with the dolphins, it just was some other factor. So there are 13 improvers and then 17, and same thing, the people that didn't improve weren't going to improve either way, okay? So that's why we look at the response. We have the 13 improvers and the 17 non-improvers is what we're going to call them. Then we're going to take those cards. So I do have 13 that say improver, and I have 17 that say non-improver. Okay, so I'm going to shuffle those up. And if you're getting your other cards ready, I'll show you that too. So I used 2 different colors, black and red. So I used, there are 13 of each suit in a regular deck of cards. So I just used, for spades, I used all 13. I just kept them in order to show you. This is all 13, 10, and Jack, Queen, King. for the improvers. So black will be improvers. And then I did red, and I've got all 13 plus 4 more to get the 17. Okay, those will be the non-improvers. Okay, so if you want to be getting that ready, you can get that ready. Okay, so first I'll do it with these little blue cards that I have. The idea is the 13 we're going to improve no matter what, and the 17 we're not going to improve no matter what. But they were in this experiment divided into 15 and 15. So we're going to shuffle into 2 equal groups and say, okay, well then this would have been the therapy group and this would have been the control group, right? Because remember we're saying there's no difference. Okay, so I'm going to deal these out. Happen to be equal, so I'm just going to go eat every other. I'm going to do 3 simulations. So I'll do 1 with this set and 2 with the regular playing cards. Okay, so I've got my 2 groups, and we want to count the improvers in the dolphin group. Okay, so I can actually just set my control group aside, and then on the next page there's a spot to record. So this will also help you know what to count. So we're going to count the improvers in the dolphin group. Okay, so I'm going to count. I have 1, 2. Okay, so let me count. I've got. Okay, so I've got 7. I have 7 improvers in the dolphin group. 7 out of 15. Okay. And then I need to do the improvers in the control group. Well, I know that there are 13 improvers, so that's going to be 6 out of 15. Okay, so the difference is going to be 7 out of 15 minus 6 out of 15. Okay, so we'll get a decimal for that. Okay, so that was with the blue cards. Let me do it again, but with the playing cards. Right, remember we want to see what's likely to happen if there is no difference between the groups. Okay, so I've got my 13 and 17. I'm going to shuffle real quick. I'm going to pause it because I want to shuffle it really well. So I'm going to pause it real quick.